Okay, so when we left off in the last video, we had pretty much finished up our shuffle and card operations, and we were ready to start implementing some game logic. So going back to this website at bicyclecards.com that I showed you at the very beginning when we started setting this project up, it gives the overview of how to play the game of war. So we know we have the deal. So the deck is divided evenly. Each player receives 26 cards, dealt one at a time. Anyone may deal first. Each player places his stack of cards face down in front of him. So that is the first set of functionality that I am going to tackle here in our game logic. Is we have a deck of cards. We have dealt out the deck. We had some logic that we built in. Is this the end of the deck? If so, we'll need to shuffle a new one. But how can we divide the deck evenly so that each player receives 26 cards? Well, we can ask ourselves, do we care about evenly dividing the deck? We know that we could just count and pull 26 cards for each player, and that may actually be an easier set of functionality, but you could come into your deck class and create a method that would then split the deck into two different decks. So I think that's what I want to do. And so I'm over here in the deck class, and we know we have a method set up for creating a deck. So looking at the website at bicyclecards.com on how to play the game of war, so each player turns up a card at the same time. The player with the higher card takes both cards and puts them face down at the bottom of his stack. So let's start with that logic. We know here that we have pulled two cards from the deck, and we are displaying those two cards. So what we need to determine which card is higher. So we do that going back to our card class. We had this enum, rank, and suit type. And remember I talked about how with an enumeration we would start with 0, so clubs would be worth less than spades, spades be worth less than hearts, worth less than diamonds. In the game of war, it doesn't specifically talk about the suit types carrying any kind of weight, right? So our rank for ace would be 0, and then a 2 is 1, a 3 is 2, right? And so if you wanted this to match up a little better, you could re-rank these cards. But honestly, when we're talking about faces of cards and things, the fact that a king is higher than a queen is higher than a jack, unless you put in some kind of filler here, which then creates a logical issue that you have to deal with, there really isn't any way that you can re-rank these so that the numbers actually match up with their values. So if we're not worried about the suits, right, the suit type, and we're just looking at rank or face value, then we could do something like this. If the selected card 1 face value is greater than our selected card 2 face value, then we know the selected card 1 has a higher value, right? So in that point, then selected card 1, which we could just call player 1 in this case, would win the hand. If not, then we know that selected card 2 has a higher value. Right, so I'm just kind of pseudo-coding some logic here. So I'm just going to say player 1 wins the hand, or player 2 wins the hand. And, you know, we're not building this with two players in mind. One is the computer player and one is the actual player. But in essence, you know, the game of war doesn't require any strategy or anything. So this is really just you clicking deal over and over again while the cards change and then seeing whether player 1 or player 2 wins. Now we know from the rules that the player with the higher card gets to take both cards and put them face down on the bottom of his stack. Now we haven't created two independent player piles, so at this point you probably want to. So if we came over to our deck class and created two new, basically, lists of cards, and we could call them player 1, and we could call the other one player 2. Oops, not cards. And then these would allow us to keep track of the number of cards in each set. So if player 1 wins the hand, then we would assign both card 1 and card 2, selected card 1, selected card 2, to that particular deck. So our player 1 deck would get assigned selected card 1, and our player 1 deck would get selected card 2. Oh, these are lists. I'm totally doing this the wrong way. I was trying to assign them like they were something else. Yep, .add is what we use for lists. Okay, and so we would do the exact same thing for player 2, but making sure we use player 2's deck. And then one of the winning conditions was the game ends when one player has won all of the cards. So we could keep track of how many cards a particular player has won. And I'm going to do this up here. I'm going to create an integer for player 1 cards. Actually, let's think about this a little more efficiently. The list is going to take care of it for us, actually. We did create a current score section that we want to be able to add data to keep track of the current score. So let's actually rethink this. Let's keep track of current score for player 1. Let's call this current scores. I'm messing with the UI here a little bit. Alright, let's go down to our text and let's use, up here. Alright, so we have current scores. I think I'm faster in the text view source today, so I hit the source button. Come over here and I've laid out one for player 1 and one for player 2. Give them names, player 1 score, player 2 score. What's that look like? Okay, so we can keep track of them here. Yeah, I think I like that better. So in here we would be able to update the score after we assign the cards. And we could even add a little toast notification in here as well. So let's actually, player 1 wins the hand. Notify the player. Assign the cards to the appropriate deck. Alright, so let's go toast, make text. Call it winner. Player 1, yeah. Toast length, let's do a short toast. Good. And then down here we'll do the same thing. Winner, player 2. Assign the cards to the appropriate deck, and then we need to update the score. Okay, so we know it's a text view. I'm just going to call it score. Find view by ID. It's a text view. And what am I forgetting? I'm forgetting what I named it. I know it was only like 2 seconds ago. Player 1 score and player 2 score is what I named it. Lowercase? It's just not registering it. Sometimes I have this happen and then I have to build in order to get it to register those correctly. There we go. I do a build and it fixes it. Okay, and so then score.text is going to equal, and what do we want it to say? Right now it just says player 1, so we want it to say player 1 and then the number of cards in the player 1 deck. This is what I was saying, it's going to keep track of it for you with the count property of the list. And count is just it's a property of lists, and it's going to keep track of the number of items inside of the list, and so we don't need a separate variable to do that for us, which I think is kind of handy. Alright, we're doing the same thing down here, except we're doing player 2 score. And this should say player 2 and update the player 2 deck count. I'm going to go ahead and give that a build to make sure. Okay, build succeeded. Make sure everything looks good. And at this point, I think I'd like to give it a run and see what it looks like. I like to make sure to have my device plugged in so I can test periodically. So I'm going to go ahead and run this and have it deploy over to my Nexus 5 that I have plugged into my machine. And so I can test it out and see if this works the way that I want it to work. And normally I would hold this up in front of the webcam so that you could see it, except usually it's blurry as crap, and then people email me and they're like, hey, why do you make such bad videos? and so I don't know I don't know if I'm doing myself any favors. Okay, so I hit start a new game, I hit deal hand. Well, here is one of the reasons why I like to go through and check on my app while I'm writing it. I've realized I've made a really weird logic error here on this counter for the deck of cards. So the logic error here is we're starting it at 0. If it's greater than or equal to 1, then we increment, and if it's greater than or equal to 51, then we know we can play. So else we're coming down here and shuffling the deck. So this isn't logically not what we want to be doing here. And so I probably want to start, I understand what I was trying to do here, using this counter as a way to increment through this array of, or list essentially, of cards. I think logically I just need to turn the signs around to make this work. So if our card counter is less than or equal to 0, then we will increment. And then if it's less than or equal to 51, we'll do our game. And then when it's greater than that, it's the end of the deck, right? So we just need to turn the logic around on that to make that work right. Let me set a breakpoint here and run and test and make sure that I've done the right thing. So looking at this, card counter should increment. That's good. We come down here, it's less than or equal to 51. We grab the top 2 cards from the deck. We set the images appropriately. We determine which card is higher. So selected card 1, let's go ahead and dig in here, is a Jack of Spades, and selected card 2 is an Ace of Hearts. And so we know that the Jack is higher than the Ace. I guess it depends on who you ask, but in this case, the Game of War doesn't determine that an Ace is a higher rank. It actually is the lowest rank. So we know selected card 1 is a higher value. Player 1 wins the hand. We're going to notify the player. So we'll make the toast, and then we will add both selected card 1. Ooh, look at that. An exception. Ooh, and you know what? I know why we're getting an exception. We never initialized this list before we tried to put something in it. So let's do that. So yes, this is where breakpoints and debugging is important. Here we initialized our card list, but we never initialized these 2 lists. So we'll just go ahead and do that in here when we create a new deck. And that will work out, I think, just fine. But otherwise, I think our logic here was okay. So we're ready to move on with the next set of game logic. So the next bit that I wanted to add in before we wrap up this part 4 video was determining how the game ends. And then in the next section we'll dig into the actual war. So you know, the website tells us the game ends when one player has won all the cards, which we would know to be this condition down here. We had previously said, is this the end of the deck? If so, we'll shuffle a new one. That's probably not what we want to do. If this is the end of the deck, the game is over. Declare a winner. Alright, so we won't do these things, right? We won't go ahead and start the game over. And all we need to do is when we shuffle out and create a deck is split it into these 2. Okay. Yep. Here's the end of my method. Alright, so we're going to make static, public, void. No, this is a private. Split deck. So after we shuffle, we'll call the split the deck into 2 piles for player 1 and player 2. Okay, split the deck into 2 piles for player 1, player 2, and that's exactly what split deck is going to do. We shuffled. Yeah, since we've already shuffled, we can probably just take the first 26 cards and put it into player 1 and the second 26 cards and put it into player 2. I think that's probably the easiest way to go about it because they're already shuffled. So let's see. For each card in, what are we calling it? Cards. No, I can't do a for each because we're wanting a particular amount. Okay. So from 0, while I is less than 25, because we're starting with 0, incrementing for I, then we want to take and put into player 1 dot add from cards position I. And then a second for loop. I'm sure there is probably a far more sophisticated way of doing this, but I am just writing off the cuff. Count. There we go. Let's take a look at this and see if that looks like what I think it's going to look like. So what this should do, in my mind, is start with 0 in the array and work through the first 26 cards, putting them into the player 1 pile. So looking at this, we should have, yep, 0 through 24. That's only 25 cards. Alright. Yep, because I said less than, not less than equal to. Sorry. Alright, we just want to double check that we're getting the correct piles here. Ah, there we go. Okay, so player 1 has 26 cards and player 2 has 26 cards, and that is exactly what we wanted. And so over here, instead of working out of one primary deck, we need to make sure selected card 1 comes from player 1. Oops, I'm still running. Comes from player 1, and this one comes from player 2. And I'm just making the modifications needed. And we won't need this counter at all. Or at least I don't, well, what are we doing here? We're incrementing. No, that's fine. We'll leave the counter. Alright, so pulling from player 1, selected card 1, from player 2, selected card 2, displaying them, evaluating them, declaring a winner, and then if the player with the higher card takes both cards, puts them face down at the bottom of his or her stack. So let's test this logic and run the application and see what I have now. And so I can start a new game, I can deal the hand, I have a jack and a 3, winner is player 1, and so we'll need to adjust the current score so that it's actually giving us something meaningful, because right now it's just giving us the number of cards that are available in our hand, which isn't a very worthwhile number. So I'm going to call this to a close because I've made an epic amount of mistakes in today's video, and I must be tired or maybe just not awake yet. So stay tuned for the next part where I think we'll be able to wrap this up, because all we really have left is to make sure that we're displaying some kind of accurate score on the for player 1 and player 2 on the UI, and then we need to implement the war, so each player turning up one card and evaluating those, which is essentially the name of the game. And so we should be able to wrap this up in the next video, and so feel free to send me any messages that you have about this. And then at the very end, if you have been having trouble following along, which I apologize for if that's true, you can always get this source code off of my GitHub, and that way you can tinker around with it, and maybe that would help if you're having trouble kind of understanding what it is that I'm doing. But I'm trying to kind of explain this as I go so that you can get into my head and my thought process, and that'll be clear. So I will see you next time.